Hi everybody. In this video I'm going to attempt to go over a problem where they gave us two different equations and they want us to find the shaded region between these two equations after we graph them. So one of the equations they gave me was y equals minus 2x squared plus 20, which is that parabola, inverted parabola. And the other one was a line, y equals 3x minus 15. So I graphed the first one, graphed the second one, saw the area in between, shaded that in blue. Okay, so we want to find that area. And I think we're going to have to use calculus to find that area. If you think about it, remember what integration really is you're adding up all these, think of this as a bunch of little rectangles that make up this area, and you're adding all those little rectangles up. And those little rectangles have a width of delta x, which is like your dx, right? So we're trying to find that blue shaded area. So what do we got to do? We have to, first thing we got to do is figure out, well, what x's does this shaded area go from? Like, what's the x value? Here, we don't know where it intersects, right? And what's the x value here where it intersects? So that's the first thing we got to do, is figure out where these two graphs intersect. So how do we do that? How do we find where two graphs intersect? So one is minus 2x squared plus 20. The second one is 3x minus 15. So to find out where they intersect, where they have the same y values, you would set these two y's equal to each other. That's a big 2 there. It's x squared. Okay, so now we have to try to solve for x. See, let's get everything on one side. I'm going to move the 2x squared over there. So I'm going to have a positive 2x squared plus a 3x. And then I'm going to subtract 20 from both sides. So that'd be minus 35. So I just moved everything over to the right side, basically. Right? So that's what I ended up with. And then I have to maybe I call it like defoil this. So you got to figure out what we would have to put in here so that when we foiled it, we would get 2x squared plus 3x minus 35. So 2x squared plus 10x minus 7x is plus 3x. Negative 7 times 5 is minus 35. We got it. So basically you got to fool around with that, defoil it. That's what I came up with. And then what do? You that zero product rule where you set each one equal to 0, because either one of those factors could be 0. So this one you get 2x plus 7, 2x equals 7, sorry. So x is equal to 7 over 2, and this one, x is equal to negative 5. So guess what? We just figured out that right here, the x value is negative 5, and right here, the x value is 7/2, which is 3.5. Okay, so that we know now that we have to integrate from negative 5 to 7/2. Okay, so that's one thing we know. But now we got to figure out what the heck we're integrating. So how do we find, what do we have for an equation to represent that area? Well, if you think about it, if you took this, if you integrated this equation, this parabola, you'd find the area under that. So it would be that whole area minus the area under the line. So it would be this whole area minus the area under the line. Wouldn't that give you the shaded area? I think it does. So we have to take the top function minus the bottom function. So the top function is that parabola. So you got to do minus 2x squared plus 20, and then you have to subtract from that 3x minus 15. Right? Okay, so top minus the bottom. So what do we end up getting? We end up getting negative 2x squared minus 3x. Watch the sign, right? You have to distribute that negative. Then you have a plus 20 and a minus 15. I think that gives you a plus 35. So basically, what is this? This is the height in terms of x of any particular little one of these rectangles that make up the area. That's the height of at any particular x. So that's what you have to integrate. So you have to integrate minus 2x squared minus 3x plus 35 dx, because that's the height times the width is your dx. Okay? So now we're just doing an integration problem, right? So let's see, can we do this? We have to take the antiderivatives. So what do we got for the first one? We have the negative 2. Then we have to do 1/3 x cubed minus 3 1/2 x squared, right? Plus 35x. And that all goes between 7/2 and negative 5. Okay. So I think I took my calculator out and I started plugging in 3.5 for 7/2, and I ended up getting negative 28. I just carried out the decimal points a few. Minus 18.373, I think. I can't read my writing. Plus 122.5. Minus, so that was when I stuck this 3/2 in for x. Minus 83.33. So now I'm putting in negative 5 in for x. Minus 37.5 minus 175. So first time around, I plugged in 3.5 in for x, and then I had to plug negative 5 in, minus, and put negative 5 in for x. Okay. So what did I end up getting? I don't know. I ended up getting 75.5417 for this, minus, or plus, it came up to a plus 129.167. Ended up getting 204.7087. I kind of like took a few shortcuts because I didn't much remember my whiteboard, but you basically, you know how it works, right? First you put in 3.5 in for x, minus, then you put negative 5 in for x. And you have to be really careful with the signs, and you have to add them all up. And I got 204.7087, so hopefully that helps. So the key here is top function minus bottom function. Find the limits on the integration by setting the two y's equal to each other to see where they intersect. And then it's just a matter of doing the integration, okay? I hope that helps. Good luck.